Good morning children, I am Poonam Bagga and today we are going to start a new chapter, chapter 3, playing with numbers. Now what is it? Are we really going to play with these numbers? Up till now you have been playing games such as Ludo and Snakes and Ladders in which these numbers were involved. Today also we will be bringing some new concepts in which these numbers will be involved, and once we understand those concepts very well, then it will always be a play to give the answers to the questions asked, to tell the factors and multiples of any given number. And this is the today's game, to find out factors and multiples of any given number. Once we understand the concept, then it will always be easy and playful to give the answers, to tell the factors and multiples of any number, and then we will be playing with these factors and multiples. So we begin our game with some toffees in our hand. Now how can you distribute these toffees? We are having these 6 toffees with us. How can you distribute these 6 toffees equally? Remember, we have to distribute equally among our friends. So just think about the possible outcomes. How can you distribute? Let us pay attention here. If we want to give 1 toffee to each of our friend, then how can we distribute? We can give 1 toffee, 1 single toffee to 1 friend, 2nd toffee to the 2nd friend, 3rd toffee to the 3rd one, 4th to the 4th one, 5th toffee to the 5th friend, and 6th toffee to the 6th friend. So in all, we can distribute these toffees, single toffee, to 6 of our friends. If I want to give 2 toffees to each of my friend, then what can be done? 2 toffees to the first friend, 2 to the second, and 2 to the third. So to how many friends are we now giving the toffees? Clearly to 3 friends. So this is another possible case of distributing toffees. Again, if I want to give 3 sweets, 3 toffees to each friend, then to how many friends can I give? 3 toffees to the first friend and 3 toffees to the second. So only 2 friends can be given the toffees now if I want to give 3 to each person, and so the number of friends will be 2. If I want to give 4 sweets to each person, 4 to the first friend, and then what do we see? Now only 2 toffees are left. And now the distribution can't be done equally. We are unable to divide these 6 toffees among 2 friends equally. So we cannot distribute these toffees in this way, taking 4 for 1 single person. So this distribution is not according to our condition, not equal. Then what next? If I want to give 5 sweets to 1 single friend, 5 to 1 single one, then we are left with 1 single toffee, and now we can't again distribute these toffees equally among our friends, between any 2 people also. The distribution can't be equal, you can see here. So again this distribution is unlikely to be done. Then what next? If I want to give all the 6 toffees to 1 single person, then clearly, since I have only 6 toffees, so I can give all these collectively together to 1 single friend of mine, and so I can write here 1, and obviously this distribution is not possible. So what we are seeing here is, we have divided or distributed 6 toffees among our friends in these possible outcomes. Okay. And what are these possible outcomes? Actually, you will find that these are smaller parts of the same number 6, and on multiplying these parts, we again get back the number 6. 1 into 6 is 6, 2 into 3 is again 6, 3 into 2 is again 6, and 6 into 1 is again 6. So actually these are smaller parts of the bigger number 6, subparts of 6. Now these smaller parts are called factors of 6. This again is called a factor of 6. all these parts are smaller parts of bigger number 6 and they are called the factors of 6. Let us have a look at the definition of a factor. A factor of a number is an exact divisor of that number. We have this number 6 and let us try to divide this 6 by all these numbers less than 6. Okay. If I divide 6 by 1, what do we get? 1 6 is 6 and the remainder is 0. So, since we are getting the remainder as 0, it means that the division is exact here. 1 is an exact divisor of 6. You can see exact divisor means there is nothing left. When we divided these 6 toffees, single toffee once, then we were left up with no toffee. So, the remainder was actually 0. And here you can see that the division is complete, exact division we have done among our friends. And so, this is the mathematical indication of that situation. No friend has been left, all the 6 toffees have been distributed equally. If we divide 6 by 2, then we get 2 3s are 6 and again the remainder is 0. So, again the division is complete, it is exact, and so this 2 is said to be a factor of 6. Here 1 also divides 6 completely, so we say that 1 is a factor of 6. Also we divide 6 by 3, 3 2s are 6. We are again left with 0 or the remainder is 0, and again we say that the division is exact or the division is complete because nothing is left. And while distributing, you can see this physically also, when we distributed 2 toffees, then nothing was left, the distribution was exact, the distribution was complete. Similarly, when we distributed 3 sweets, again no toffee was left, the distribution was exact and complete. So, we say that 1 is a factor of 6, 2 is a factor of 6, 3 is a factor of 6. Then if we divide this 6 by 4, then what do we have? 4 1s are 4 and now we are left with 2 as the remainder, and now we say that the division is not exact, not complete, because now the remainder is 2, it is not 0. And just have a look at this situation, when we tried to distribute the sweets in this proportion, 4 toffees to one single person, then what did we find? That 2 toffees were left. The division was not exact, it was not complete, 2 toffees were remaining here, and so we were unable to distribute in this manner 4 sweets. So, here also we are having this 2 as the remainder. The same 2 toffees that were left there are now shown mathematically here in the form of the remainder. Also, if we divide this 6 by 5, what do we get? 5 1s are 5 and we have 1 as the remainder. Again the division is not said to be complete here because the remainder is not coming out to be 0. The remainder should be 0 for exact division, or the remainder should be 0 for a number to be a factor of this given number. Since here we are not getting the remainders to be 0, so 4 is not a factor of 6 and 5 is again not a factor of 6. We are not getting the remainder as 0. And you can see here also, when we tried to distribute 5 sweets or 5 toffees to one single person, then again we were unable to distribute equally, we were left with 1 sweet, 1 toffee. So, the distribution was not possible equally in this case also. So, that 1 toffee which was left is shown as the remainder here in case of division. And if we divide 6 by 6, we have 6 1s are 6 and again the remainder is 0. So, again we can say that 6 is a factor of 6 itself. So, now we are able to tell what are the factors of 6. They are 1, 2, clearly 3 is also a factor, and 6. These are the 4 factors of 6. and if you analyze, you will find that these are the numbers which on multiplying give us 6 in the following combinations. 1 into 6 is 6, 2 into 3 is 6, 3 into 2 is 6, 6 into 1 is 6. On multiplying they give us 6, and also they are smaller than 6, and also this one is equal to 6. So, whenever we try to find out the factors of any given number, we will have to just think about the smaller parts of that given number, and then on multiplying, if we are getting that number, then we say that those two smaller numbers are factors of the greater number. Let us take some more examples. If I take a number, say 10, then how can it be broken up into two parts, smaller parts? You can think as 2 into 5, yes, 2 5s is 10, clearly yes. 5 into 2 is also 10, but we need not to write it separately, both are one and the same thing. If we take 2 first and 5 then, or if we take 5 first and later on 2, both are one and the same thing, as you learnt the commutative property in case of whole numbers for multiplication, same here. Then what next other combination is possible for 10? How can we break up this 10 into two parts? Just think over it. Yes, the other possible way is writing it as 1 into 10. So what do we see here is, we can always multiply a number by 1, that's always possible, and here we have 2 and 5 also, 2 into 5. So what we have done? We have broken up this number 10 into two parts in such a way that we get 10 again on multiplying them. So now we can say that the factors of 10 are 1, 2, 5 and 10. Okay. Now think of some other number, say 25, let us take it 25. Now I need to tell the factors of 25. For this I will have to think that how this number 25 can be broken up into two parts such that on multiplying we get back 25. Just try to break up this 25 into two parts. Just think it over. Yes, you are getting it right. It's 5 into 5. 5 5s is 25. Do we get this 25 in some other way also? Obviously, when we multiply it by 1, we will get again 25. Is there any other possibility also? No, these are the two possibilities. So from this we see that these are the smaller numbers which on multiplying give us 25, and again these two are the numbers which on multiplying give us 25. So we can say that factors of 25 are 1, this 1, then 5 and then 25. No need to write this 5 two times, it is okay if I write it once. This all will be very much clear as we will be taking up some more examples, but before that let us know something more about factors. 1 is a factor of every number. You can see every number can be divided into smaller parts taking one single piece every time, as we distributed sweets, toffees, taking one each time. So we were able to divide the sweets, the toffees among our friends, taking up one single toffee at one time. So 1 is a factor of every number. You can see it here. 1 is a factor of 10 also, 1 is a factor of 25 also, and 1 is a factor of 6 also, and similarly it is a factor of every number. Then what next we have? Every number is a factor of itself. Every number, when we spoke about 6, 6 is a factor of itself. Again 10 is a factor of itself, 25 is a factor of itself. You can see this. Then what next? Every factor of a number is an exact divisor of that number. Yes, we have seen that the factors divide the number completely. The remainder comes out to be 0. You can check it in case of 10 also. If we divide this 10 by 2, this is 2 5s are 10 and we get the remainder as 0. So what we see is 2 divides this 10 exactly, completely. The remainder that comes out is 0. And in place of 2, if I try to divide this 10 by 3, say, it's 3 3s are 9, and we are left up with this remainder 1, and now the division is not complete. So this 3 is not a factor of 10. From this we can easily see that 3 is not a factor of 10. So for a number to be a factor, it is compulsory that it divides the given number completely. The remainder comes out to be 0. By complete division we mean that the remainder should be 0, nothing should be left. This is the mathematical thinking and this is the practical thinking. You can see how we distributed the sweets practically, and this is the mathematical representation of all those situations. And now, which is the next point? Every factor is less than or equal to the given number. You can see when we were discussing the factors, all these 3 numbers are less than 6 and this number is equal to 6. Taking into consideration the factors of 6, we find that this is equal to 6 and the remaining are less than 6. In case of 10 also, this one is equal to 10 and the others are less than 10. Here also this is equal to 25 but these are less than 25. So we see that every factor is either less than the given number or it is equal to the given number. And what next? Number of factors of a given number is finite. By finite we mean that it is countable. We can easily count them on our fingers. Here also we can count how many factors are there for 6. They are 4. 1, 2, 3, 4. We can easily count them. Here also we can count the factors of 10. 1, 2, 3, 4. There are 4 factors of 10. Here also we can count the factors of 25. They are 3 in number. 1, 2 and 3. So by finite we mean that the number is limited. We can easily count them. So these are the major points related to factors. Now we will understand them much better with these examples. Write all the factors of 18. Here we are taking this number 18. For finding the factors, what we need to think is how to break up this 18 into 2 numbers such that we get the product as 18. Try to think it over. We will start with the smallest number, which is 1. Okay, we will write here 1. Now with what number should we multiply this 1 to get 18? Clearly it's 1 into 18 equal to 18. This is the first pair. Now we move on to the second table, which is 2. Just think it over how to break this 18 taking 2 as one of its number. It can be written as 2 9s are 18. Okay, we are breaking this 18 into 2 parts such that the product of 2 parts is 18 again. So 2 9s are 18. Now we think about the next table, which is of 3. Just think about the table of 3. Is 18 present there? Yes. 3 6 are 18. So we can write it as 3 6 are 18. Next we move on to the table of 4. Just think it over. We know that 4 4s is 16 and 4 5s is 20. So 18 is not coming in the table of 4. So 4 is not a factor of 18 in other words. Then come on to the table of 5. We know that 5 3s is 15 and 5 4s is 20. So again the number 18 is missing in the table of 5. So 5 is again not a factor of 18. Then we move on to the table of 6. It's 6 3s are 18, 6 3s are 18. And what we see here is 3 and 6 have already we have taken. So the numbers have started repeating now. Once you see that the numbers start repeating, stop at that stage. We can always remove this. we will take each pair only once. So now we can write the factors of 18. How? We will write in this U shape, taking in this pattern. 1, 2, 3 and then 6, 9, 18. 6, 9 and 18. These are the factors of 18. Once again have a look what we did. We started with this number 18 and now we are looking for sub parts, smaller parts of 18. Two parts taken to be ones. First we started with 1 and clearly 1 18s is 18. Then we moved on to 2 and then we were thinking about the table of 2 and then we knew that 2 9s is 18 and we have written it. Then we came to the table of 3. 3 6 is 18, we have written it. Then we moved on to table of 4. We know that 18 is not in the table of 4. 18 does not come in the table of 5 also. And then in table of 6 we get 6 3s are 18. So the repetition has started and now we will stop and we can now easily write all the factors as 1 2 3 6 9 and 18. And now you can see 1 is a factor of 18. 18 itself is a factor and all the other factors are less than 18 and this one is equal to 18, yes, and all these are less than 18. So all the properties have been fulfilled that are of a factor. And yes, you can always check if you divide any of these number, if you divide 18 by any of these numbers, you will get the remainder as 0. The division will be complete. So these are the factors of 18. We take up one more example, that of 30. We have to find the factors of 30. So again what we have to think? We have to think about numbers such that the smaller parts, such that when we multiply them we get 30 back. We start with the table of 1. We know 1 into 30 is 30. So the first pair is 1 into 30. Then we will take up the second pair. We start with 2 now. Take up the table of 2. Just try to think it over. If you are unable to think, you can also divide this 30 by 2 and get the number. 2 1s are 2, 1 0, 2 5s are 10. Yes, the remainder is coming out to be 0. The division is complete. So 2 is a factor of 30 and we will multiply this 2 by 15. So 2 15s is 30. Then we come to the table of 3. 3 10s are 30, yes. Then we come to the table of 4. Is it there 30 in the table of 4? You can just think 4 7s is 28 and 4 8s is 32. So the number 30 is missing in the table of 4. So 4 is not a factor of 30. Then move on to 5. Yes, 5 6 is 30. Very good. And then we move on to the table of 6. So 6 5s is 30 and we have taken 6 and 5 already. So the repetition has started. We will stop here. We will now we know that 6 5s is 30, but these two numbers we have already taken. Now the numbers have started repeating. So we will stop here. We will not move further to the table of 7 8 9. No need to do that. Once the repetition starts, we will stop here and we have all the factors of 30 as, we will start from here, 1 2 3 5 coming down in this way and then taking in this way, 6 10 15 and then 30 itself. So again you can check by dividing 30 by each of these numbers, you will get the remainder as 0. So this means the division will be complete and also all these numbers are less than 30. This is equal to 30 and 1 is again a factor of 30. So all these numbers are said to be factors of 30 because in these combinations they give the product equal to 30. So by this time I hope that the concept of factors is clear to you. Whenever we ask about factors of any given number, then we try to break it up into 2 or sometimes more than 2 parts such that their product is equal to the given number 30 in this case. And again we will be taking up more examples later on. Now we move on to a different situation, and it is you take 8 minutes to walk around a circular path. You can see this is a circular path, this blue one, and if you take a round, complete round, if you start from here and then take one complete round and come back to the same position, you take 8 minutes. How much time would you take to complete the successive rounds? So you are not stopping after one round, you are taking the rounds again and again. So the time taken to complete the first round, it's given, it's 8 minutes. I am writing the time in minutes, okay. Then what will be the time taken to complete 2 rounds, the second round? Obviously it will be 8 into 2. First round in 8 minutes, second round in 8 plus 8, that is 8 into 2, it will be 16 minutes. This was 8 into 1 round, 8 minutes. This is the number of rounds that we are taking. Then for third round, again how much time will it take to complete now the third round? Total time that we are talking is, it will be 8 into 3. First round in 8 minutes, then second round in 16 minutes, then third round in again 8 minutes, 8 3s are 24 minutes. You will take 24 minutes to complete the third round. Then what next? For fourth round, again you will take one more round of 8 minutes, and the total time will be 8 4s are 32. I suppose that you are getting my point. For first round simply it was 8 minutes. For 2 rounds you took 8 plus 8, so it's 8 2s are 16. Then for 3 rounds, first round 8 minutes, second round 8 minutes, third round 8 minutes. So it's nothing but 8 3s are 24. And then for fourth round, first round in 8 minutes, second round again in 8 minutes, third round again in 8 minutes, and fourth round again in 8 minutes. So in all it's 8 4s are 32. Now just pay attention at these numbers: 8, 16, 24, 32. What is special about these numbers? These numbers we get on multiplying 8. You can see we are multiplying this number 8 by these other numbers, and then we are getting these red circled numbers. So there is some connection between 8 and these numbers. What is that connection? Just see that we are getting these numbers when we multiply 8 by any other number. It can be any other number. By here they are 1 2 3 4, we can multiply by 5 also, 6 also, 7 also. So the other numbers we are multiplying by 8, and then we are getting these numbers. These numbers are called multiples of 8. All these are multiples of 8. 8, 16, 24, 32. Why these are called multiples of 8? Because we get these numbers when we multiply 8 by some other number, then we are getting these numbers. So these numbers are called multiples of 8. So what is a multiple? A multiple, a number is a multiple of each of its factors. Here you can see when we were multiplying 8 and 2, 8 2s are 16, then this answer that we get after multiplying, it is called the multiple, and these two numbers are called the factors of 16. So we can say 16 is a multiple of 8. What we can say? 16 is a multiple of 8, and since we get this 16 by multiplying 2 also to any other number. So we can say that 16 is a multiple of 2 also. Why? Because when we multiply 2 by any other number, it is 8 here. When we multiply this 2 by 8, then also we are getting 16, and when we multiply 8 by 2, again we are getting 16. So actually this 16 is called the multiple of 8 also and the multiple of 2 also, and 8 is called a factor of 16. What else can we say? 8 is a factor of 16. And similarly this 2 is a factor of 16. Make it clear into your mind that what is a multiple and what is a factor. The smaller parts are called the factors and the bigger number is called the multiple of those smaller numbers, and the smaller numbers are called factors of the bigger number. To be precise, smaller numbers are called the factors of this bigger number, and the bigger number is called the multiple of these smaller numbers. And clearly by multiple we mean a bigger number by getting by multiplying, and on multiplication we get a bigger number. So always this bigger number is a multiple and these smaller numbers are factors. We can take some more examples. For example, if we write 4 into 5, it's clearly 20. Now identify which is the multiple here. 20 is the multiple. Multiple of what? 20 is a multiple of 4 also, and 20 is a multiple of 5 also, because we get this 20 on multiplying 4 to some number and also on multiplying 5 with some number. So we get 20 as the multiple of 4 also and of 5 also. And now identify the factors. Clearly this is the multiple, and which are the factors here? Factors of what? Factors of 20. 4 is a factor of 20 and 5 is again a factor of 20, because these are smaller parts of 20, and on multiplying these smaller parts we are getting 20. So these smaller parts are called factors and this bigger number is called multiple. I hope you are getting my point and you are relating the two concepts, factors and multiples, very well. Now again we move on to the multiples. Some more points we have. Every multiple of a number is greater than or equal to that number. You can see here, in this case also you can see the multiples are greater than the given number. You can see this 16 is greater than 8, 24 is greater than 8, 32 is again greater than 8, whereas it can also be equal to itself. This 8 is equal to 8. So what do we see? The multiple, you can see here also, this is the multiple, it is greater than 4 and 5. So multiple of a number is always greater than that number and also equal to that number when we multiply it by, suppose we multiply 20 by 1, what do we get? 20. So this is again a multiple of 20 and a multiple of 1. So when we talk about multiples of 20, it will be equal to itself and then it will be greater than 20. Here if we take multiples of 4, suppose it will be 4 ones are 4, 4 twos are 8, 4 threes are 12. All these are multiples of 4 and these are greater than 4 and this one is equal to 4. So we say that multiples are greater than the given number and also equal to it. Then the number of multiples of a given number is infinite. Just compare it with that of factors. The factors were limited, we were able to count them. The multiples are infinite. By infinite we mean that we can't count them, they are many in number. When we take the multiples of 4, we can't stop here. We can have more multiples. 4 4s are 16, then 4 5s are 20, 4 6 are 24 and so on, so on, so on. the multiples will go on increasing. Since the numbers are endless, they go on till infinity. Similarly, their multiples will also go on till infinity. So, we are unable to count the multiples. Whereas, when we were talking about factors, you can see the factors were finite in number. We could easily count the factors. Here there were 4 factors, here there were 3 factors. So, we were able to count the factors, whereas we can't count the multiples. They are infinite in number, they are many in number. And also just have a look, the factors were less than the given number or equal to it, whereas the multiples are greater than the given number and or equal to it. So, this is again a difference between factors and multiples, and the second difference is the number of factors is finite, whereas the number of multiples is infinite. They move on and on and on. You can take any case. As we will be taking the examples, it will be much more clear to you. Every number is a multiple of itself. Yes, you can see when we wrote 8 ones are 8. So, from this we can say that 8 is a multiple of 8. Similarly, when we write 4 ones are 4. So, 4 is a multiple of 4. So, every number is a multiple of itself. Clearly, you can see here. Now, we take a few examples. Write first 5 multiples of 5. So, how do we get a multiple? How will we get the multiple of 5? We will multiply 5 by some other numbers and then we will get the multiples of 5. Since we are talking about first 5, so we will start with 1, multiplying 5 by 1. Then what we get is 5 ones are, it's 5, this is the first multiple. Then multiply 5 by another number 2, it's 10, multiplied by 3, we get the third multiple, multiply it by 4, we get the fourth multiple, multiplied by 5, we get the fifth multiple. It is nothing else but the table of 5, you can see. So, the first 5 multiples are 5, 10, 15, 20 and 25. These are the first 5 multiples of 5. There are other multiples also. You can say 5 sevens are 35, 5 tens are 50, 5 hundreds are 500. Taking a bigger numbers, it is also a multiple of 5. You can multiply 5 into 120, it's 600. Again 600 is a multiple of 5. You can take much more bigger numbers, or you can see that when we multiply 5 by any number and get any number, then this is said to be the multiple of 5. Clear to you? And since here first 5 multiples have been asked, so we have written the first 5 multiples by multiplying 5 by 1, 2, 3, 4 and 5. Then we have to write the first 5 multiples of 7. Again we can simply write the table of 7. 7 ones are 7, 7 twos are 14, 7 threes are 21, 7 fours are 28, 7 fives are 35. These are the first 5 multiples of 7. Now, don't think that these are finite, we are able to count them, they are 5. We have been asked only 5 multiples. Otherwise, there are many more multiples of 5 also and of 7 also. They are infinite in number. But here in this question, we have been asked only 5 multiples, first 5. That's why we have written only 5. Otherwise, there are many more multiples of 5. You can always multiply 5 by any other number and you will get one multiple of 5. So, there is no end to it. Then, what are perfect numbers? A number for which sum of all its factors is equal to twice the number is called a perfect number. We understand with these examples. Consider this number 6. We will write its factors first. We had taken it 1, 2, 3, and 6. We have seen it earlier, the factors of 6 are 1, 2, 3 and 6. Now let us try to add these factors. 1 plus 2 plus 3 plus 6. It is what? 6 and 3 is 9, 10, 11, 12. And what is 12? It is 2 times 6. 2 into 6 is also 12 and the sum of factors is also 12. So such a number in which the sum of its factors you can see is twice the number. This sum 12 is 2 times the number 6. So such a number is called a perfect number. Take the case of 28. We will try to write its factors. To write the factors, what we have to think? We have to break this 28 into two smaller parts, starting from 1. 1 into 28. Then with 2. 2 into 14, it's 28. Then 3. Is 28 present in the table of 3? No, 3 9s is 27 and 3 10s is 30. So 28 is missing there. Come to the table of 4. Yes, we know it's 4 7s are 28. Then in table of 5 it's not there. In table of 6 it's not there. Then in table of 7 we have it and 7 we have already taken. So the repetition has started. We will stop here. And the factors are 1, 2, 4, taking up in this way and then in this way. 1, 2, 4, 7, 14 and 28. These are the factors of 28. Now let us add these factors. 1 plus 2 plus 4 plus 7 plus 14 plus 28. Add these numbers, what you get? It's 3 and 7 10, 14 it's 10 and 24, 28 and 28 it's 56. And what is it? If we multiply 2 and 28, we get the same number 56. So we find that the sum of the factors is equal to 2 times the given number or twice the number. By twice we mean 2 into 2 multiplied by that number. So that's why this 28 is again a perfect number. So by this time I hope that you have understood what are factors and what are multiples. We now take some examples from your book. Write all the factors of 68. How we will start thinking? We have to break this 68 into two parts. We will start with the table of 1. Clearly 1 into 68 is 68. That's very easy. Then 2 into what is 68? Just think it over. You can also divide it by 2 to get the answer. If you divide, it's 2 3s are 6 and 2 4s are 8. Yes, the division is complete. It will be 2 into 34. Again, just think over about the table of 3. Is 68 divisible by 3? Let us try to divide this 68 by 3. It's 3 2s are 6, 0, then 8. It's again 3 2s are 6. We are left with remainder 2. So is the division complete? No. So 3 is not a factor of 68. Then we move on to 4. Let us divide this 68 by 4. This you have to do in your rough part. 4 1s are 4, 2 8, 4 7s are 28. Yes, we are getting the remainder 0 and now this division is complete. So we can write here 4 17s is 68. Then move on to the table of 5. Is 68 present there? No. Then in table of 6, again you will not find this 68 in table of 6. You can always try by dividing 68 by 6. If you divide 68 by 7, again you know that 7 9s is 63 and 7 10s is 70. So 68 is not there in table of 7 also. In table of 8, it is again not there. In table of 9, you know it is not there. In table of 10, of course it is not there because we have 8 at the end. and in table of 10 each number ends with a 0. Then 11 6 is 66, 11 7 is 77, again it is not divisible by 11. So, you just see how we need to move on till we do not get a repeated number. Then we divide by 12, again we know that 12 5 is 60 and 12 6 is 72. This 68 is missing in the table of 12 also. Think about the table of 13, 13 6 is 78 and 13 5 is 65. Again 68 is not there in the table of 13. So, these numbers are not the factors of 68. Move on to the table of 14. 14, is it present there 68? You will see that 68 is not in the table of 14 also, 15 also and 16 also. Then we have 17 4s are 68. But what do we see? We have already written these two numbers. So, from here the repetition starts, and so we will stop here, and we have the factors of 68 as 1, 2, 4, 17, 34 and 68. These are the factors of 68. I hope you have understood it. Then we move on to the next example. Find the factors of 36. Again we will have to break this 36 into two parts such that their product, their multiplication comes out to be 36, and we will start with the table of 1. I hope you are getting the point that how to find the factors. We start with the table of 1 and we will find out two numbers every time such that their product is equal to 36, such that when we multiply them we get back 36. So, 1 should be multiplied by what number so that we get 36? Yes, it is 36 itself. Then 2 into what is 36? 18 2s are 36. You should be learning the tables also. You should be knowing the tables. So, 2 18s is 36. Then what should be multiplied by 3 to get 36? Yes, it is 12. 12 3s is 36. Then what should be multiplied by 4 to get back 36? It is 4 9s are 36. Then 5. Is 36 present in table of 5? Is 36 divisible by 5? In other words, you will see not. 5 6 is 30, and then we have 5 7s are 35, 5 8s are 40. So, 36 is not there. So, we will not take it. Then yes, 6 6 are 36, and here you can see the repetition has started. 6 has come 2 times. The repetition is started. So, we can stop here. You can now easily write the factors of 36. Factors of 36 are, starting in this way, U shape, starting from 1, then 2, 3, 4, 6. No need to write 6 2 times, it is enough to write it once. So, we will write it only one time. Then 9, 12, 18 and 36. So, these all are factors of 36. Then we have one more example with us. Write the first 5 multiples of 6. What do we mean by multiples? The number that we get on multiplying 6 by some other number. So, 6 we have to multiply by some other number, and the answer that we will get, it will be the multiple. Okay. So, with what number should we multiply 6 to get the first multiple? We have to write the first 5 multiples. So, I should multiply this 6 by what number to get the first multiple? That is, it should be multiplied by 1. So, 6 1s are 6, and this is the first multiple of 6. Then again we need to multiply 6 by any other number to get the second multiple. And what will it be? 6 2s are 12. This is the second multiple. Similarly, we can write 6 3s are 18, 6 4s are 24 and 6 5s are 30. So now the first 5 multiples of 6 are these numbers: 6, 12, 18, 24 and 30. And you can see all these numbers are greater than 6 and this itself is equal to 6. So the multiples are greater than the given number or equal to it, whereas the factors are smaller than the given number or equal to it. In case of 36, you can see this one is equal to 36 and the remaining are smaller than 36. So this is a difference between factors and multiples. And also remember, when we are multiplying two numbers, the answer that we get, here suppose we are taking this 18, then 18 is a multiple of 6 also and 18 is a multiple of 3 also, whereas 6 and 3 are factors of 18. So whenever we get only one single statement such as 10 into 2 it's 20, this means that 20 is a multiple of 10 also and 20 is a multiple of 2 also, and here 10 and 2 are the factors of 20. I hope the concept is very much clear to you. Now you can take up your own numbers and try to write down their factors and their multiples. So play this game till we meet again in our next class. Thank you.